Engineering is a world of precision, but before the detailed calculations, there's a crucial step, the quick estimate. Picture a client in a factory asking, "How big a pump do we need to empty this tank in an hour?" You need an answer now, not after hours of analysis. This is where thumb rules, simple, experience-based shortcuts, become invaluable. They bridge the gap between theory and practice, letting you make fast, confident decisions on-site or in meetings. Pumps are everywhere, and knowing how to quickly size and select them is a fundamental skill for any engineer. These rules won't replace detailed design, but they'll give you a head start and help you avoid costly mistakes. Let's dive in and unlock the essential thumb rules for pump design. So, what are thumb rules? They're quick, practical formulas born from years of experience that give you rough answers fast. Think of them as the engineer's shortcut, not perfectly accurate, but close enough to get started. For example, a carpenter's thumb was once a rough inch. In engineering, a thumb rule might estimate pipe size or friction loss. These rules are distilled wisdom, not a replacement for detailed calculations. Use them for initial estimates, then confirm with precise analysis. Their real power is in simplicity, focusing on the most critical factors and providing a sanity check for your detailed work. If your complex math and a thumb rule don't agree, it's a red flag. Thumb rules are your safety net, catching errors before they become expensive problems. Use them wisely, and they'll make you a faster, more reliable engineer. Pumps are the heart of fluid systems, and getting them right is critical. Thumb rules let you quickly estimate flow, head, and power, crucial for early project planning and field decisions. When details are missing, these shortcuts help you select a preliminary pump, get budget pricing, and keep projects moving. In emergencies, thumb rules help you verify or replace pumps fast, minimizing downtime. They also make technical discussions clearer. "We need about a 10 horsepower motor" is easier than a deep dive into equations. Thumb rules are a common language, building consensus and confidence. Master them, and you'll stand out as a practical, effective engineer. Here are 8 essential thumb rules every engineer should know for pump design. Flow rate. For domestic water, estimate 150 to 250 liters per person per day. For cooling towers, use 3 gallons per minute per ton of refrigeration. Head loss. Assume friction losses are 10 to 20% of the static head. Pumping up 50 meters? Add 5-10 meters for friction. Pump power. Estimate power, kWe, as Q M3S XH M X 9.81. Efficiency. Assume 60 to 70% efficiency for standard centrifugal pumps. Motor selection. Choose a motor rated 10 to 20% higher than the calculated pump power for safety and longevity. Suction pipe sizing. Make the suction pipe one size larger than the pump's inlet to reduce velocity and prevent cavitation. NPSH margin. Ensure available NPSH is at least 1 to 2 meters greater than required by the pump. Pump speed, lower RPMs below 1500 for slurries mean longer life, especially with abrasive or viscous fluids. Pump location. Place the pump close to the source tank and below liquid level if possible, maximizing inlet pressure and protecting against cavitation. Mastering these rules gives you a solid foundation for any pump challenge. They're your go-to shortcuts for fast, reliable decisions. Use them to estimate, check, and communicate, then refine with detailed analysis. These rules save time, reduce errors, and build your confidence. They're not a substitute for full design, but they're the best way to start. Keep them handy and you'll be ready for any pump sizing question. With practice, these rules become second nature. Let's see them in action with a real-world example. Let's apply these rules. You need to select a pump to move water from an underground sump to a cooling tower 30 meters up at 90 mM/h. First, Estimate total head static head is 30 meters. Add 20% for friction, 6 meters, totaling 36 meters. Convert flow 90 mathria h 3600 elos in 0.25 mad maths. Estimate power 0.025 b adds 36 adds 9.81 0.7 12.6 kilowatt. Add 20% safety margin. 12.6 adds 1.2 equals 15.1 kilowatt. Standard motor size 18.5 kilowatt. For your proposal, specify a pump for 90-pound Matribag H at 36 meters head with an 18.5 kilowatt motor. In minutes, you have a solid, defensible starting point. That's the power of thumb rules: fast, practical, and reliable. Now, let's talk about when not to use them. Thumb rules are for estimates, not final designs. They work best for standard conditions like water at normal temperatures. For unusual fluids like viscous slurries or critical systems like boiler feed water, thumb rules can be dangerously wrong. In these cases, detailed calculations are essential. Technology and materials evolve, so always question the assumptions behind a rule. Use thumb rules for quick checks and early planning, but never as the sole basis for high stakes or complex designs. The best engineers know when to trust a rule and when to dig deeper. Combine old wisdom with new knowledge for the best results. Thumb rules are a guide, not a guarantee. Use them smartly and you'll avoid costly mistakes. Let's recap the key pump thumb rules. Estimate flow by application. Add 10 to 20% for head loss. Calculate power with QXH x 9.81. Efficiency and size the motor 10 to 20% higher. Use a larger suction pipe. Maintain an NPSH margin. Prefer lower pump speeds for tough fluids. And place pumps low and close to the source. These rules are distilled from generations of engineering experience. They're not magic, but they're practical, fast, and proven. As you gain experience, you'll refine these rules and develop your own. Write them down, practice, and use them to build your confidence. Next time you're asked for a quick pump estimate, you'll be ready. This is how you become a practical, reliable engineer. It all starts with a few simple rules and the confidence to use them. Good luck, get designing.